Hello, I'm Barry Palmer. We are going to watch a builder build a Vanguard Sev. The builder is Dave Crawford of Bothell, Washington, which is a suburb of Seattle. And although he has experience in building antique automobiles, he has never built a Sev. And he's going to take the standard plan set and kits of Sevtec, build up the Sev, and we will take this Sev right on through his first flights. I'm over at the home of Dave Crawford in Lake Forest Park, which is just north of Seattle, and we have come here to look at his Vanguard start. He started this project about 3 weeks ago, and as you can see, he's well along, and this is the time to fit the bow panels.
This stuff sets in about a minute to a minute and a half, they say, in the directions. Then I gotta get the 19.5 inches, I believe it is. And that's about where the top of that 1x3 is going to be. I'm going to glue this together just 3-inch passes or so.
Oh, I edited that out.
And I got that little block down there in the corner to kind of get that part going in there.
After all of these joints are glued up, inevitably the last joint will not be tight, and you'll usually have a triangular gap, as is shown here. This machine happens to be more accurate than most. The important thing is these forward corners be 19.8 inches above the plane of the bottom in this Vanguard case. And the trick for handling these is to cut out a foam wedge and fit it in this groove, or you can fill this groove with micro balloons by merely taping the backside and putting the fill in and letting it cure out.
Yeah, it sure is. Right on the point.
I'll reach in.
There.
Yeah.
And that's what I got here. And that's about 19.2. That's about 19 too. cuts pretty good just like that.
Fitting the bow piece is somewhat of a trial and error process. All you have to do is just start chipping away at the foam and it will go, and you can fill in large volumes that you've removed with micro balloons and glass it in place.
That does it. Okay. The date is, and I'm back at Dave Crawford's, and he's coming right along on his Vanguard. You can see that he's got the bow pieces molded in. He's going to save the glassing of the upper surfaces so that he can smooth the entire surface and blend the entire surface in with the aft deck, which he has also placed. Let's take a closer look at the aft deck. You'll notice that the aft deck is also unglassed, and he has mounted doublers, wood doublers, fore and aft of the aft deck, and these will take the bolts that hold the air drive on. And you'll notice that the contour of the shroud has yet to be sanded in. Fan bore is not glassed, and you'll notice the well aft of the fan bore, and this will allow room for the idlers. You'll notice that the underside of the aft deck is glassed, and you can see the fan shroud, which is built up in the brick fashion as it was done in the Scout video. And now he's ready to place the inboard surfaces of the two flotation compartments. It should be noted that these two inboard flotation compartment skins are different sizes as the fan bore is offset. And basically you should trim them to fit, and their location is not extremely critical. It's now time to locate the scoop bar. This bar divides the airflow from going into the main cushion and going into the tubular part of the aft and side skirts. This scoop is positioned 3 inches ahead of the rear of the fan bore and about 1.5 inches down below the fan bore, and it's not real critical as far as positioning goes. This piece here fits down something like that over the top of that piece of 3/4 by 2.5. And then it's going to go in here. And then we've got this other piece that goes in like here.
And it's only glassed on one side. See, this side isn't glassed, and the reason for that is so that we can warp it around to fit. This is what the bow panel looks like with the hull inverted.
Well, I'm back at Dave Crawford's again, and the date is, and you can see he's come quite a ways. He's starting to add the hardware in the first build-up to his hull. I thought I'd discuss a little of the hardware. This is the recoil starter. Now, the first rule is the rope on the recoil starter should be replaced with rope from a domestic supplier for outboard motors, because the rope they put on these machines seems to be too weak. Basically, you remove the guard that is on the engine and use a belt clamp to hold the flywheel and take the flywheel nut off. You replace the flywheel nut with this extended nut. The cup that engages the pawls on the starter goes on top of this nut, and then this other screw holds the assembly together. And that's how your recoil starter goes on. One little item that you might consider is a bullseye level. You can install this in the craft, even on the floor or on the side rails, where it's level, and you can tell how the machine is trimmed out. And when you're operating the machine should be nearly level to slightly nose up when it's in proper trim. Now we'll go over and look at the exhaust system for this engine. Exhaust manifold, and make sure everything is clear. Your throttle cable is clear when you install your throttle cable. It fits thusly. And this is the muffler, and it fits against the engine and is bolted to the engine thusly. And one thing you should remember is that these mufflers seem to be cracking in these two joints, so build a plate that fits in here and braze that to the muffler, and hopefully that'll stop the cracking. Note the throttle cable attachment to the engine, as you can see right near the exhaust manifold. That little plate in there rotates about the axis that you can see just above the throttle cable, and that keeps the governor engaged. So we're using the governor on this engine, and the governor seems to work on these Vanguard engines, unlike a lot of the other engines that I've worked with. Assembly. It is imperative that these idler assemblies be aligned so that the belts pass onto and off the pulleys in a straight line. And another aspect is the touch bars. There's one there, and there's one there. These are absolutely vital in this craft, or the belt will hop off. This drive has been incredibly reliable, but these touch bars are an absolute requirement. And if you do not use these touch bars, your belt is going to come off. It's almost guaranteed. On the pulley, and the bearings are installed on the upper end of the air drive. Note the way the fan bore extends above the deck surface. The fan blades can be fitted to the fan bore very precisely by adding a small amount of microballoon mix or Bondo light to fit the fan as it's installed on the engine, and the engine is bolted up tight to the truss stand. When you finish up your hull construction, if the dimensions are slightly out, you may have to adjust those dimensions by cutting the edge of the hull off, because the skirt dimensions are meant to fit the hull. So to bring these dimensions into
spec, sometimes you have to shave a small portion of the outer hull edge off.
Go over a few details with an engine up on the bench. This is your exhaust manifold. This is your throttle link. Now normally these garden equipment engines use a rather crude type of push-pull cable or Bowden cable with these clips here, either here or here. What we're going to do is use a marine cable. Since this is the throttle of a vehicle, it's very important that it work. And also the lever has to move about 3 or 4 times as far as this throttle linkage moves. So you can get the forces down on the lever and you can get a feel for the control for making power settings. This is not required in the garden equipment engine, but is very definitely required in a vehicle. The type of cable is the typical Morse cable, and we have to adapt the infitting to the throttle of the engine. And we do that by drilling out the small hole in the throttle and then putting a ball joint for the marine cables in there. Thusly, now I might warn people that they supply this hardware to put that ball joint onto an assembly, get rid of it, and use an elastic stop nut. These setups seem to shake loose on these smaller engines, which vibrate quite severely compared to a 4, 6, or 8 cylinder marine engine. So very definitely use an elastic stop nut. Now once the ball joint is on, the rest of the ball joint assembly can just be screwed onto the cable. Then it's a simple matter of pulling this spring-loaded device back and popping the cable on. And that's a very positive joint. Now the other end of the assembly, this end here, should be clipped to the engine stand via this groove. Never put a strap over this, which is merely a dust shield. Make sure that the strap or whatever device you hold this cable engages this groove in the cable. And to open up the throttle, you pull on this. The governor, meanwhile, will try to shut it. So this is the governor rod. That should all be left in place. The governor seems to work on these Vanguards. Now another thing I might point out is the spark plugs have a problem in salt water of salt water shorting to this head bolt, and they've conveniently placed it right near the gap between the spark plug boot and the wire. Now there are 2 solutions to this. One solution is to purchase this commercial waterproof boot, which consists of a plastic part that's one piece. It's put on the wires, and these rubber gaskets are placed over the spark plug and over the wire. Another solution is to use this sort of material, which is shrink fit tubing. Put several layers of shrink fit tubing on this part of the wire until you build it up, and then you can put a larger piece over the outside of the whole setup. And this type of setup has been working on my Vanguard for about 3 years now. And another thing you should note is all these bolts on the hardware, on the tin of the engine, have to come off, because to get a strap wrench on the flywheel, you have to remove this sheet metal. These bolts should be put back with Loctite. One thing that should be noted is the choke control. You can use the relatively crude hardware of the garden equipment industry for this particular control, or you can go into any automobile shop and buy a accessory choke handle. And here's the choke lever. You pull it to close the choke. A couple of more notes on these cables. Even though they appear to have lots of flexibility in this area, try to install them so that when the control is taken through its full motion, the change in angle of the cable is at a minimum. And you should always have a backup nut on your quick disconnect. And these rubber seals should be in place to keep moisture from getting into the cable. It should be pointed out that these engines are also equipped with a anti-dieseling solenoid. So whenever the engine is shut down, this solenoid is de-energized and it chops the fuel supply off. Well, if your electrical system fails and you're out on the water somewhere in the middle of nowhere and you have a recoil starter, it's not going to do you much good if your fuel supply is cut off because the electrical system doesn't work. The engine has magnetos and it's got the recoil starter, but you're not going to get it started. So it is advisable to remove this anti-dieseling solenoid. Barry again, and I'm back here at Dave's, and the date is, and we're here to look at some of the details of his Sev. He's done a beautiful job on his electrical system. For a few of the electrical and mechanical details of Dave's craft. In the first place, you can see that he's got a good set of rubber padded stops for his steering system. And they appear to be made with a rubber bushing, which could be as simple as a rubber cork from a hardware store with a bolt through it and a washer on each end. He's also got a key start for his electric start engine. He's got the mag short switch and a horn. He's also got a cigarette lighter here. Since you sometimes need an electrical supply, the cigarette lighter is the usual form that you get it in, and you can hook your cell phone up or your radio or your GPS or whatever with this system. You'll notice this is all under the deck, which is a good idea in that it keeps the electrical stuff dry. However, I would suggest possibly placing the magneto switch on the outside so that one could make an emergency shutdown if he desired, and then be able to turn it back on if that were the case. That would minimize any problems. Dave has installed this pull type mechanical device. You pull on it and it shorts the mag when the clip on the end of it comes off. I can't recommend this device for Vanguard, especially if you're using it in moving water, because once you shut the craft down, it's down and there's no way of easily restarting it. However, in any kind of a situation, such as a race situation, where you might be working with other vehicles in close range, which quite frankly Vanguard's not built for, you can use this sort of a device. It's used on most English racing type air cushion vehicles because they have a habit of tossing people in the water. And these craft, we feel quite comfortable about going on 10, 20 mile overwater crossings with this sort of hardware, without this sort of hardware. And quite frankly, I consider it a danger. So whenever you're operating in moving water, you should not have this sort of a device connected. He's also using running lights. Normally the bow light is out closer to the bow, but he's going to place his further back. He's also got a fire extinguisher up front. And he's also installed bungees underneath the deck so they can be hooked in any way he wants to hook them in for storage of, in the bow here, for storage of lightweight type of materials like sleeping bags and things like that. And he's got more of the bungees in the rear for heavier objects. And he's also stores his what is euphemistically called auxiliary means of propulsion that you're required to have on smaller watercraft.
And this one has something that's very valuable. It has a boat hook on it, so he can hook onto things. This is his control system for the flaps. He hasn't put the skirt on yet, so this is not hooked up, but he's just routed cords through eye bolts. A very simple way to do it and quite adequate. You'll notice he's loomed his wires together with plastic wire ties. He's done a very neat job. You'll also notice that he has used stainless steel carriage bolts to hold his skids on. This will get rid of an annoying problem of hitting chair legs on these things and having them catch while you're trying to reset your weight. You'll find that the passenger and pilot will move these seats around, and you want to be able to slide them around. And normally in the first operation areas, the pilot will sit there and the passenger will sit about there. And as the water gets rougher, the passenger seat moves further back to keep the craft in balance. Now, when you're starting out, it might not be a bad idea to have a bullseye level, as shown here. This bullseye level will indicate the attitude of the craft if it's set parallel to the bottom of the craft. And you want to run with the bubble just slightly ahead of the circle, and you'll know you'll have your craft in trim. Of the electromechanical hardware in the nose of the craft. Note the rubber stops on the steering. And here's the bullseye level, and the handle with the two cords attached to it is for the purpose of pulling the bow skirt vent flaps open to control the two forward cushions. You'll note that Dave has installed a battery on a rather peculiar angle. The reason he can do this is it's a gel cell. It looks just like an ordinary battery, but it will not spill. Right above the battery you'll see a starter solenoid, and just to the right of the battery you will see a drain plug. It's just a normal boat drain plug, and right below it there's a little eyelet that can be bought at a marine store that holds the skids on just as the carriage bolts held the skids on, and this is an ideal device to tie down more cargo. To the right you will notice a ammeter and his horn, and there's the discharge of a bilge pump. This is just a simple little plastic housed unit that rests on the bottom of the hull, and it sucks in the bilge in that small impeller. This is a first-class craft, and something like this doesn't normally appear in this small of a craft. The fuel tank is nothing more than your standard outboard unit, and it has the regular fuel line with a squeeze bulb. And very importantly, it has a quick disconnect, and this quick disconnect is handy because an air cushion vehicle can get places other vehicles cannot get, and there aren't any gas stations in these places. And Dave is looking at the anti-dieseling solenoid. You'll notice that this craft is a two-barreled carbureted engine. This is the 20 horsepower Vanguard. Dieseling solenoid in the Vanguard 20 horsepower engine. This solenoid must be removed, or if you lose your electrical system outside, you will not be able to get this engine started. It has a starting solenoid with a slug in it, and the slug can be easily removed. And that's all you have to do. Pull it out, remove the slug, and put it back in. I would use Loctite on it though, and you're back in business. The fuel pump has to come off to get the sheet metal off the top of the engine. So here you have to take a brand new engine and do a lot of disassembly. It might make you nervous, but it has to be done.
All I gotta do is put a handle on it.
Yep.
Remember to use Loctite on all these fasteners that you install the sheet metal with.
Barry again. I'm over at Dave's, and the date is, and we're here to look at the elements to his skirt. I'm sitting on the bow skirt, and you can see the remaining elements of the skirt out in the background. The bow skirt has the control flaps already installed. These flaps open up the two compartments in the forward cushion. You can open one of them for a turn or open them both to drop the nose and braking. They also have metal in them so that they can be bent to conform to these holes as closely as practical when the skirt's in its final configuration on the hull. This is the partition. This is part of the bow skirt. This particular joint will be assembled after the skirt is on the vehicle. And here's the other skirt, part of the bow skirt. That will be assembled after the skirt is on the vehicle. These are the forward quarter skirts. And this is the divider skirt. This goes right down between the two front cushions so you can generate pressure in one or the other cushions. Moving back in the craft now, these are the two halves to the partition skirt. You'll notice Dave has already put reinforcing on this particular part because this part of the partition skirt will end up under the skid at times, and a buildup of material here is to reduce the tendency to damage. These are the side skirts, the largest panels. And you'll notice now we're getting into foam flotation. The foam is strapped down every 4 inches or so with a strap of the skirt material so that this is all loose and the foam can easily move around. And the ends of the foam are pop riveted to the skirt so that the foam will not escape. If you do not pop rivet these in the skirt, the foam will escape within a couple of hours of operation. Further back to the aft skirt components, this is the aft quarter skirt. Notice it still has this foam flotation. These are little fill panels that have to be installed after the skirt is installed to the hull. This is the aft skirt, and this small panel is installed here, and this will eventually tie into the flow splitter that's underneath the lift fan, and the air that goes behind it goes into the main skirt volume, and the air that goes ahead of it goes into the cushion of the machine. And this skirt element also has the drain flap. This allows water that will inadvertently get inside the skirt. It allows it a way to get out. And be careful with this flap. It's easy to install it in backwards so that it scoops water rather than getting water out of the skirt. This area here should be faired in carefully with cement so that these layers will not peel away. And this is one of the only areas where the skirt isn't literally shingled together to prevent water from hydraulicking open the joints. To assemble the aft skirt to one of the aft quarter skirts, we've already assembled one of the aft quarter skirts to the aft panel, and this is our second glue joint. We're out in the sun because in the Pacific Northwest in May, you're lucky to get the sun, and you should have at least 70-degree Fahrenheit temperatures, and the sun can help you in preventing the possibility of condensing moisture out on the glue as the solvent evaporates off, because this process cools the glue down
And if you get moisture in the joint is not going to work. The first thing you do is turn the aft skirt over so that its exterior surface is up. It's in the middle of the curved part, and he works both ways. First, put the glue down on the surfaces that will contact each other.
Boy, I don't think I'm getting that 1 inch coverage down there.
Then all you have to do is fold the tabs over, and the curved part is glued together.
Ain't right on the button.
For the ease of gluing the aft quarter skirts to the aft skirt and the side skirts to the aft quarter skirts, the juncture between the forward quarter skirt and the side skirt is not quite as simple. As you can see here, they appear to not fit at all. So you may have to cut a few more V-notches, and generally you're going to have to fasten these one flap at a time, because the joints sort of have to be forced into position. So you have to start approximately at the ground contact line and glue this straight section between the forward quarter skirt and the side skirt first, and then you're going to have to cut more flaps, more of those little V-notches, to get the side skirt to conform to the forward quarter skirt. We have to add the extra V-notches to get these two panels to fit into each other. Remember, just 5 at a time.
Now it's time to start installing the skirt. The skirt's held to the hull with contact cement primarily to hold it in place. The metal strips and the screws are what actually hold it in place.
An issue about installing the skirt is that you should be able to pull the skirt out like this, and this should touch without a wrinkle there. It's easy to pull it in too far, so that this contacts it like that, so this is smooth.
And we're going to put on the skirt. We're going to attach the inner portion of the skirt to the hull. Skirt anchors are started at a line just at the forward edge of the bottom plane of the craft, and that curious double flap arrangement on the inboard side of the forward quarter skirt should line up with the front of that bottom panel, and the forward quarter skirt should be pulled somewhat tight against the hull for these to line up. At the point where the plow plane and the bottom plane fit together, the forward quarter skirt is stretched tight against the sides of the hull, and that curious joint in the flap, the inboard flap, should line up with the bottom panel forward edge, and the skirt just simply trails over the edge of the bottom panel, and the skid holds the skirt in place. Holes through the skirt material to take the 1/4-inch bolts that hold the skids in place. The splitter bar that splits the air from the interior of the cushion and the interior of the skirt, and Dave is about to install the flap from the skirt that will divide this air. It's installed with a metal strip. And this is the completed installation of the scoop. And now we have to install the fill panels. Because it's so cold, to make these joints we are going to have to use a hairdryer on it. The material, the vinyl material, will hold heat quite well. And what we do is we heat up both surfaces to be glued, apply the glue, and then we heat up the glue joints and then slap them together, and we can get a good joint just as we did out in the sun when we made the main joints for the skirt. In the hole in the aft of the skirt, that fill panel, as drawn in the plans, does not fit all that well, so he did it in 3 parts. The fender washers held in place with number 8 screws is what's used in the plans, and it's also what's used in the prototype, but very possibly we can go to the strips as shown in the Scout video, and it makes it a little easier to do. Dave uses a heat gun on this material because it's quite cold now and we wouldn't get a good joint. Roughly 15 seconds have passed over a joint about 2 feet long is what you need, and the material holds heat quite well and it should be warm to the touch. Then you can apply the glue and you can hit it with a heat gun again. Remember to watch for a frostiness on it, which possibly indicates water, and this will destroy the joint. And now it's time to install the partition skirt. Again, we're using the screws with fender washers, but perhaps the metal strip as shown in the Scout video would be a better proposition for this installation.
Getting white on me.
Pressure equalization port in the front of the quarter skirts. These are very important to control pressures inside the main bag part of the skirt. Forward 2 cushions complete. And that's the main cushion. And the skirt is complete and installed on the vehicle. Three, two, one, zero. 3, 2, 1, 0. Try the diagonals also. Yeah, this is going to be okay.
It looks pretty good, huh?
Yep. Looks flat to me, as flat as you can expect. Try the other diagonal. Oh, there's no doubt.
Huh?
Even though that piece of steel is rather flexible, there's simply no doubt that's flat.
Well, we're here at Dave's again. The date is, and we're ready to do the skirt trim. The idea of this exercise is to get the running surface into as perfect a plane as we can get it. And to do this, we have to put ourselves on a flat surface. We should tie the machine off. In this case, the surface is not level, but it is flat. So we should tie the machine off or it will simply slide down the hill.
The machine is blocked up to its intended hover height, and what Dave will do is start the machine up, and then he will lay a felt tip marker flat on its side on the smooth surface, and he will draw a mark on the bow skirt, and the trim is just below this mark by the width of the pin. Notice that major sections of the panels are pop riveted together at their ends. Dave's put a little patch over the outside of these pop rivets. Anywhere you have extreme high stress areas, such as this bow panel and the side bow panel coming together, it's a good idea to install a pop rivet. There's a pop rivet there. There's also a pop rivet on the divider skirt where it attaches to the partition skirt. The startup sequence is much better. Barry again, and the date is, and it looks like Dave has gotten everything together and we're ready to roll.
Right day.
Keep your spine in shape.
getting
Yeah.
it professionally done?
Sometimes.
That fellow that was just in there, he didn't have to worry about losing his skirt and rolling in the whole vehicle with a finger skirt? Or is that more worrisome on him?
Oh, okay.
And I have
Besides that. I just did that for you, Dennis.
we're going to do is bend the large hoops for the full guards. This particular guard is a prospector guard, and since this uses a 6-foot propeller, we will need 2 lengths of this conduit. This conduit is 3/4 inch, and we will braze the 2 pieces together right on the center line at the top of the guard when we are finished bending these hoops. This particular conduit has a good start is it's marked in 1-inch increments. And the way we bend this conduit is to use an ordinary hardware store conduit bender. These benders are easy to use if you happen to weigh about 220 pounds, but there is nothing subtle about the way they bend, so we have to exert control because we're going to be bending this hoop in small increments. Normally you use a 3-roll bender, which is a device that allows you to feed the tube into the rolls at the end and then crank it through and your bend comes out smoothly. However, these are hard to obtain, and it's better if we can use ordinary hardware store items. This conduit bender is one item. This is a furniture clamp, or a pipe clamp as some people call them. We have a workbench here, which is nothing but an old piece of plywood with a couple of 4x4s underneath to assure flatness. And we have various other blocking, like this piece of 1/4 inch plywood here, to adapt to the particular dimensions of the conduit bender. And we have a piece of 1/8 by 2 by 2 steel angle C-clamped to the whole assembly with a small block of plywood clamped to the assembly to adapt to this particular conduit bender. And we're ready to bend. Now the way we figure out how to make these bends are that we have to appreciate we're going to do it in small increments, and the smaller the increment, the less bend per bend angular wise we're going to make as we feed the tubing through this setup. This particular bend is for a 77-inch in diameter hoop for the prospector guard, and the total circumference for a 360-degree circle is around 241 inches. So we know we have, for each 90-degree sector, we have approximately 80 of these 3-inch segments for the whole circle, and 20 of these segments for just a 1/4 circle, and we're going to bend a little bit more than a 1/4 circle. Now since there are 80 per full circle, all we have to do is divide 360 by 80, and that determines the angle that we're going to bend in each bend. Now the conduit bender has a pipe handle. You mark the pipe handle at a certain dimension, and we figure out how far this dimension has to move as we produce the bend to give us that correct angle per bend. And we do it this way. Find our first inch dimension. These inch dimensions don't always start at the start of the conduit. Then we apply the furniture clamp, sort of loosely at first. And we can draw a starting line right there. And then we make our bend, having previously calculated that this point here has to move over 3 inches to give us the right angle for this particular 3-inch increment bend. We crank it over. The mark will be on this side of the pipe, so you will see them just disappear. Now that we've cranked it up to the full bend, we have to realize there's also a spring back. The tubing deforms elastically for a while, and then it
deforms plastically. And when it performs plastically, it deforms permanently. However, we have to do the elastic part first, so we have to bend the tubing a little bit more than our intended angle, like that. And here we have a second line here. That allows for what's known as spring back. Then we can let off on the bender and check, and we can see that we have the correct angle, but we had to bend further than that angle to achieve it. Then we take the tubing and we advance it along 1 3-inch increment. Remember, we're using marks that are on the tubing that the manufacturer has supplied on this particular conduit. And we have the marks. We'll never come back to the starting mark again, but we have the other marks. We crank it up to our first mark. That's the angle we need. And then we crank it past that angle to allow for our spring back. And now that the clamp has no weight on it, we can see it springs back to the correct angle. We just keep feeding it through. The tubing should be kept flat to the bench so that the arc will be all in a plane. The handle of the conduit bender moving around like a big pointer, telling us which angle we've bent the tubing to. We're bending this conduit every 3 inches, so 360 degrees for a 77-inch diameter hoop. Center line of the conduit would amount to 4.5 degrees per 3-inch segment. In that 4.5 degrees, we can look out along this pointer, which is the handle to the conduit bender, and the tangent of this angle, which is 4.5 degrees, is what determines how far we go, but we have to go a little bit further for spring back. Guards that use 1/2-inch conduit can be bent up over your knee merely by drawing a pattern on the floor and bending the tubing until it aligns with the pattern. However, this works so well, it might be an easier way to do even the smaller conduit guards. Obviously, with a guard this big, we're going to have to make some final bends over larger spans with final adjustment, but the basic curvature of the guard is there, and it's repeatable time after time after time. In forming the hoops, the next step is to join the individual 4 assemblies that you've bent up previously into 2 hoops by joining them at the center line at the top of the guard. You should put a little doubler, which would be a piece of conduit sliced in half, maybe about 1 inch to 1.5 inches long, to make that joint extra strong, and braze that joint. After you've assembled the 4 elements into 2 hoops, then the next thing is to place these bars across the back of the guard. This is the rear hoop on the guard. Place these bars across the back of the guard and shape this assembly so that it's a little bit lopsided, because remember, the thrust line on Prospector is set over to the left by about 1.5 inches. I would maybe make the guard lopsided by 1 inch and then set it to the side by another 1/2 inch to line the propeller up. After this assembly is set up, the next step is to braze these members on the cylindrical part of the guard. These members have been fish-mouthed by merely running them on a flat sander, a belt sander. It can be done with a disc sander or a grinder. And they are just held in place so they can be tacked thusly with this drywall square. I had previously leveled up this whole guard assembly, and I can use levels on the square or a regular carpenter's level to make sure that these are upright. I use a slightly reducing flame on the torch and tack it in place. First thing you do is you preheat the joint, aiming the torch basically at the heavier member because the lighter member or the edge of a member will heat up faster, and get everything glowing to a little bit of a red color. Then apply the braze material. This is a flux coated brazing rod, 1/8 inch I believe, and if the braze starts to burn, back off with the torch flame. If the braze is too cold, get the torch closer. You're doing the forward hoop. It obviously can't be bent perfectly to agree to the rear hoop when you try to match the two hoops up. So what you do is you set the lower hoop in the position you want the hoop to conform to, and then when you put the forward hoop in place, you heat it and bend it to line up with the aft hoop so that when you push it around, it doesn't bend the aft hoop out of the alignment that you've previously chosen. And it's done as follows. You look along it, and you pour the heat to it. You look along it and get a smooth bend. You can heat about 1 inch of this tubing with this particular torch. And you can heat it in spots and push it so you still get an apparent smooth curve. Sometimes you may need a little force to get things to come around.
be made to the guard, and this is best done on the hull or on a pattern that I've drawn on the pavement for the rear of the Sev. And in this case I have the Spanish windlass to bend the guard, and I've strung plumb bobs from the upper part of the guard and also from the rudder points, and these plumb bobs will tell me how I'm moving the guard. And remember, when you use these plumb bobs, there's this spring back that you have to take account of, and this Spanish windlass is a way of generating extremely high forces. Although one way to put the wire on is to put it on with plastic wire ties. Some people may prefer to braze it on. And the trick here is to avoid oxidizing the wire, so you really have to pour the heat to the conduit part of the guard, or you will oxidize the wire and later on it will probably break. You'll notice I'm holding the wire taut against the structure with welding clamps. And you merely pour the heat to the conduit of the guard itself, with the rod held in the background. Take a little heat and braze away. Looks like it might take forever, but it's actually quite a fast process. This wire is about 16 gauge, 1x2 mesh.
Putting windows in your vinyl top can be a little bit tricky. You should first cut out a cardboard form, the shape of the window, so that when you lay the vinyl fabric down, you can shape your window properly, and use a soft vinyl, clear vinyl, 15 mils, 20 mils thick for the window itself. This framework will easily get out of shape if you don't watch what's going on, and you should use your template to line things up. This is where it gets out of shape. This piece of paper has to go down underneath the vinyl, even on a surface that you don't want to preserve, because you have to remove it before you paste the window down, or you will get cement all over the clear spots of the window. So after putting it underneath, reshape and relocate the window so everything's squared away, and then put weights on it so that things don't slide around. Another piece of paper to keep cement off of the window. And we're ready for gluing. I try to get the glue right out to the edge in this case, and when I pull the paper away just before gluing the joint together, none of this glue will get on the window itself. It's nice to trade the side that the can is on, because this stuff tends to drip everywhere. About a ½ inch overlap should be sufficient for strength. And there you have your first joint. And here's the completed window for the Sev, very flexible. And it will wad up and take a certain amount of abuse when folding the top. And not only will it keep you dry, if you have a liquid-cooled Sev, it will provide insulation so you can heat the cabin. Side curtain is done. It's held in place to the hull with a bungee that just goes around 2 small hooks that are bolted to the hull side. This type of setup should be built so you can prop it away from the hull so you can get air circulation when the machine is stored, or the inside of the hull will get quite moldy. When 2 engines are installed on Surveyor, the thrust engine is actually attached to the V-frame that supports the propeller and the belt load. And the engine is completely free of the hull itself, and I have put 2 screw jacks, one here and one here, so that I can tension the belt and then tighten these 4 bolts after tensioning the belt, so it gives us a minimum problem setup for
achieving belt tension.
Builder Brian Phillips is starting a company called Amphibious Marine that builds the Surveyor, and he calls it the Amphibious Marine Vanguard. Uses the same engine and drive and propeller and fan as Surveyor. It is a beautifully built machine, and it is a lot of fun. And not only is it a lot of fun, it has the most modern setup you can ask for. It uses, if you wish, a modern EFI engine with the computer brain and all. And this machine would be an ideal machine for such uses as hydrology studies or search and rescue. It's also a quiet machine, but mainly it's a lot of fun.
far out. How did the cost be looking at it? I'd rather be able to go up there. I came all the way from Monroe after that, I think.
They come up the river from Monroe earlier in the day.
Wouldn't
all the
that
way
be
up.
a ball?
Yeah, me and this cameraman.
The one that I did? This is really